Good, oh, good afternoon, everyone. In the last week, we worked on a storage platform, if you guys remember. And this week, we're going to be doing the same thing, working on the same project. I've made a bit of progress over this last week, and we're going to make even more progress today. First, I'm going to show you what I was working on mechanically, and then after that, we are going to work on a schematic for the thing and finish soldering it up. So let me show you what I've built since. If I come here, if you remember in the last video, I had this top and bottom plate. Oh, looks like something broken here. Yep, there we go. So if you remember, we had this top and bottom plate where each actuator was evenly spaced. That led to a lot of issues. If you saw the short I posted last week, and I can show you guys right now what happened. If I come here, yeah, just a second. Let me show you guys what I mean. So if I do screen share full, yep. So in the previous stream, what happened was I laid out these linear actuators evenly across the three platforms, which caused a lot of movement like this. The fun part about a storage platform is that it's very rigid. It won't move unless the linear actuators move. But you can see in this short, there's a lot of movement without the linear actuators moving, which isn't ideal and definitely not what we want. And I actually mentioned that further in the short, if you look at like even Wikipedia, the graphic of a storage platform has a bunch of has them offset to form a bunch of triangles, because triangles are the strongest structure. So if we look back at what I've done since, I reprinted the top and bottom plates such that I am forming these triangles. Where do I want to be? This way. Yeah. So now you can see it's super rigid. I'm not getting any movement out of that. That's looking a lot better. And then the platform only moves when these linear actuators are actuated. So this is a much better design. It turns out that geometry is super important because this is super rigid now. Much better than I had last week. See, there's not that much wiggle. So that's doing pretty good. And that's plenty for an animatronic. You kind of want extra wiggle. It adds a little more life to the animation. So what else can we do? So we have this now super rigid platform, and what we need to do is we need to be able to draw it, to control it. And in order to control it, what I want to do, here we go, is drop a schematic. So if I get KiCad going real quick, I can show you. I haven't started much of a schematic yet. I figure we can work on that today. Here we are. Like I've mentioned in previous videos, I really like KiCad for designing these schematics. I found them to be really helpful. Additionally, I can pull up the drive. In the last video, I made a spreadsheet detailing which pins I want to use for what. So the storage platform has 6 servos on it. So I need 6 outputs, one to tell each of those 6 servers how far to extend. The eyes consist of 2 individually controlled RGB LEDs. So I need 3 outputs for each LED, one for each color in the LED. I need one servo output to control the blink function. So that's the eyelids moving up and down, and one for the wing actuator to make the wings move up and down. The animatronic I'm basing this off of, let me show you that, is this animatronic I built a really long time ago. His name is Yabbit. Here we are. So this is my Yabbit animatronic. Let me move this down so we get a little better view. This is my Yabbit animatronic. He was slightly inspired by an animatronic at Disney called the Voidoos, or something similar, from the Guardians of the Galaxy ride in Disneyland. In the queue, there are some animatronics, vaguely alien shaped, pretty much the same body shape. So what I want to do with this animatronic we're working on today is to take this whole neck platform, use this Stort's platform as the neck platform, build a whole bigger animatronic, and this way he'll have a very expressive head because he'll be able to move in all directions. So his neck will be super expressive, and I'll be able to convey a lot of emotion like that wouldn't otherwise be possible with just like a standard 2 or even 1 axis neck like this had. In the previous version, all he could do was tilt his head forward and back. So this 6 degree of freedom head will provide a lot more emotion than this old version could. So if I come back to this one. So what I have going is the blink and then the wing actuator. And then I will also need some pins for the actual target of the laser gun on the ride to hit. And what those electronics look like are these electronics. I don't think I have them here with me just right now, but here. No, I don't have them. They're basically just like the same IR sensor receiver that you see on a TV remote or on the TV. Then the laser gun's a remote. And I have a whole video on this. If it's not quite making sense, the video explains it a lot better than I am right now. But basically, when you shoot the gun, it shoots an IR light flashing at a specific frequency that sensor looks for. And one of the cool things I've tested with that is it actually will cut straight through felt material, and that's what I'm going to build the animatronic out of, so the target can be inside the animatronic, and when you shoot it, you'll still get points. So what I need to do is then set up the GPIO on my schematic here. I'm going to reference an old schematic I have set up, not this one. And what I'm going to do is I want to leave it possible on this animatronic to hook it up to a CAN bus in the future, just like I did on all the electronics on my ride. And the reason I want to make that available is if I want to create a full show scene involving multiple animatronics or showpieces, I'll be able to do that pretty easily just by hooking up a CAN bus. That way one can be the master of the show scene. It can send messages out to all the other elements of that show scene and control the whole scene as one big cohesive unit without having to link them all over Wi-Fi. So what I'll do is I'll leave this CAN bus, I'll leave the pins I need for a CAN bus module expansion in the future, just non-connected for now. So that I'm going to need GPIO 16, I'll leave as a no connection, 17 is a no connection, 18 is a no connection, 19 gets to be a no connection. 20 gets to be a no connection. And that's about all I need. And again, I'm just referencing one of my old schematics here. This one specifically was for the motor controllers on the ride vehicle. So I'll leave these 5 pins open for future expansion using that CAN module. And then, referring back to my spreadsheet here, I can start setting up some of these header pins. So one thing I need to include is a lot of header pins to connect our servos to. And to do that, I'll just use the generic dew point header pins available in the KiCad library. So if I get male header, or I guess male pin 3x1, let's see, connector, here we go, 3x1 pin. So the servos all require a 3x1 pin, and I will just lay out basically, let's see, how many do I need? I need 1, 2, 3, 4, 6, 7, 8 servos, so that's going to be 8 of the same 1x3 pins. Which way do I want it? Just like that. There we go. And as I'm laying these out, one thing I'm thinking of is I need to lay these out in such a way that the wiring's not too hard to follow on the schematic itself. And I'm not really thinking about the actual board layout quite yet. I'll do that once I actually get to soldering up the proto board. But for now, I'm just focusing on the actual wiring and what wire goes where to make this actually work. So as I connect everything, okay, and then I'll go back and rename these. I'll call this Store Platform 1, Store Platform 2. So what I'm doing right now is I'm setting up these pins, setting up the pins such that each one of these pins goes to, each one of these 3-pin headers goes to a servo. Because if we look at a servo, just here, each servo is terminated with a 3-pin female header, just like this. So what I'm laying out on the schematic now is a 3-pin male header for it to mate to, so that a 3-pin male header for it to mate to, so that I can lay out the wiring as it is right now. It goes, 1 goes to ground. And since there's 6 servos in the Stort platform, I'm laying out the 6 pin headers that will connect to it and labeling them each by which leg they're connected to. 5, Stort platform 6. Yes, there we go. And then I'll start connecting these pins to where they're actually going to go. Luckily, servos are super easy to connect to. I want ground. So I'm basically just going to have one ground down there at the bottom, which comes up and connects to every single servo's pin 1. And pin 1 is the servo that is the pin of the servo wire. That's not what I wanted. Is the pin of the servo wire that should always be tied to ground. Another way you can tell is it's the brown wire. So as soon as I get this going, I'll show you. On the servo, there's 3 wires. It goes brown, red, orange. Let's see if it'll focus. Focus. Yeah, there we go. Kind of. There's a brown, a red, and an orange. Brown is always ground. Red is always 5 volt or 6 volt. And orange is the PWM signal that tells it which position to go to. In this case, pin 1 is the brown one, so that's going to be ground. And then I'm going to attach a 5 volt signal or a 6 volt signal plus 6 volt. And that comes from the power supply, and that goes to the middle pin, pin 2, which is the red wire on the servos. There we go, just like that. And then the final pin actually goes directly to the Raspberry Pi, so it's pretty easy to set up. And if I set these upright, I'm just going to go straight down the line. Nice and simple. So this Stort Platform 1 goes to GPIO 0. GPIO 1 goes to Stort Platform 2. GPIO 2 goes to Stort Platform 3. 3 goes to 4. 4 goes to 5. 5 goes to 6. 6 goes to 7. And 7 goes to 8. And I forgot to pull these 6 volts down, but that's no big deal. That's super easy. And then I'll name this one iBlink, and this one gets to be wing flap. So pretty simple, pretty easy. Then the last thing I want to do, or the next thing I want to do, is I want to bring in some 4-pin connectors, and I'm going to use these for the LEDs. So this will be pretty nice because I can do 4 pins, 1 for each color, and then 1 for ground. So I'll actually just pull this ground down so I can use it here as well. 1, 1. And then these LEDs actually need some resistors. So I'll grab some of those, some resistor. And these need to be 220 ohm resistors. And that's 1 on each of the legs of the sensor here. Oops. Come back to wire. Boom. 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 Okay. Then this goes up to 8, 9, 10. 8. 9. 10. Okay. Then I want the same bunch of resistors down here, just like that. And this goes to 11. Let's bring this over so I have a little more space. There we go. And final one here. Nice and simple. Cool. So these animation-based platforms usually end up a lot like this, where you have just a ton and a ton of outputs and very few inputs. Especially for a sensor like this or servos like this, because servos have their own control loop built in, you don't need sensors back. You just kind of tell it where to go. So just adding those resistor values, and I'll call it left eye, right eye. So there we go. That's our output side done. And if we look at this again, it's pretty simple. It's just the servo outputs, then it's just the colors for the eye outputs. Trying to think if we need anything else. We don't really need anything else here for the power. What we do need is to then run power to the Pico, and that gets to be the ground, comes to the Pico ground. And then, let's see, I'll put a button on the run pin and between run and ground. And the reason I want to do that is to have an easy way to reset it. Switch. Contact. Let's see. Button. And I want switch push closed. There we go. So I'll put this on the run pin, and on the other side, oops, it goes to ground. This is always something good to include on microcontroller-based projects. It's super easy to do, and it makes programming a lot easier. This way I can restart it, test it again, and I don't need to completely unplug it and replug it in later, which is always helpful. Finally, last step is to add a diode between VSys and the 6-volt power supply. The reason you want to do this, as outlined in the Raspberry Pi Pico user manual, is that I want to be able to power it from the 6-volt power supply as well as from USB when programming it. If you have both plugged in at the same time, you'll actually short them together, and you can cause really bad damage to the Raspberry Pi Pico or to the whatever computer you're plugging it into, which I really don't want to do. So what I do is I include a diode between the VSys and the 6-volt power supply. That way there's no backfeeding possible from the USB into the 6-volt power supply or vice versa. So you don't create any big damage or any damage at all on the Raspberry Pi Pico or the laptop. So I just want to grab a diode. Let's see if there's just a generic diode. There's not. I want the INO47. And we point it towards the VSys, just like that. And then the other side goes to the V6, 6 volts. The final step then is to do the V6 goes to the diode, and then I need a screw terminal to represent screw terminal 2. And this is the incoming voltage to the project. So one of these goes to ground, and one of them goes to 6 volts, just like that. So now what this means is you plug power into these screw terminals here. That powers all of the servos, as well as the Raspberry Pi Pico, Pico W, and then we'll also include, do we need anything else? I don't think we do. Then the last thing to include is actually the target. Let's see if I have a target schematic ready to go. I don't think I do. If I remember though, they're very simple targets, and I'll actually show you how I'll find something like that right now. If I come here and I'll go like 38 kilohertz IR receiver circuit. Let's see, Arduino. Oh. Let's see, not quite what I want. Let's see. I actually have the sensor right here, I believe. Yeah, here we are. So these are the little target sensors that I'm talking about. Oh, let's see, here we go. So these little target sensors, they have 3 pins, a power, a ground, and a signal. So what I want to do is find how to set up one of these, because I know there are some extra resistors involved. So it's an 18388 IR receiver. Let's see, go away. Here we go. So I knew it was super simple. Super duper simple. And I'll add that right in here. And I'll actually just grab this and pull it over a little bit so I have some more room. Let's see if this is in the inbuilt component library, 838. Doesn't look like it is. It's unfortunate. IR receiver. So it's an interesting thing. When you're doing a schematic like this, it's not like I'm going to set this up to send out to a PCB manufacturer. I'm soldering this right here. So I don't like necessarily need to use the exact model number, just something that has a similar signal. But I do want to find one that's at least close, because I don't want to set up my own schematic right now, or a little symbol. Let's see, it's not in power management. Maybe in here. Let's see. Not really anything here. We'll just call it like a 3-pin. Here, this should be good enough. Oh boy. Let's just call it. I'll include 2 of these here. I lost it. Here it is. And I'm just going to copy this schematic here over. And I actually want to pull the 3.3 or 3V3 volts off of the Raspberry Pi Pico to power these. So I get the VCC gets to be 3.3 volts. And then I'll put a resistor in there between the 3.3 volts and the ground. Pull that up so it actually makes. There we go. Then the out comes up to the pin, as well as getting a resistor between a pull-up resistor. What this pull-up resistor does, this 10,000 ohm resistor I'm placing right now, is it holds the signal on the Raspberry Pi Pico high until the sensor detects something, which pulls it down to ground. In general, that's a pretty common use case. It has a distinct name called the pull-up resistor because it pulls the voltage signal up to whatever voltage you're working on. Can I delete just that? No. So like I was saying, it pulls the voltage signal up to that 3.3 volts until the sensor detects something, which pulls it down to the ground. I want another ground pin. Connect that straight to the ground. And then I'll basically just copy this same wiring right to here. I guess not. Let's see. Copy just the resistors. Slap that down there. Pull this over. Boom. Then this comes up to here to GPIO 15, and the ground gets connected to ground. And what we actually have here, we'll just call this IR receiver, and then we'll call it the head target, and the body target. body target. There we go. So now, if we come back to our camera, what we actually have is a target set up so that I can place it in the head and one that will go in the body. That way, when you're riding the ride with the laser gun, you'll be able to shoot at the Yabbit and get points for hitting either the head or the body. And I'll be able to assign different maybe reaction animations to the animatronic, as well as different points amounts that you'll score for pulling that off. And now, if I look back here, full scale, just looking at the schematic, it looks like we have everything we need for this to be a working animatronic controller. I'm just thinking through anything else we could possibly need to control this robot. The only other thing I'm thinking is I might want to add an extra servo. Do I have space for an extra servo? Let's see. Yeah, I have pins for 2 more servos. What I can actually do is I can disconnect these like this, and then I can grab all this, pull it over here. Maybe I can rotate it. There we go. That's the thing. Mirror. Oh. So then this head target will actually come down and around to pin 21 here. And the body target goes to pin 22. And that frees up a little more space here that I can use for an extra servo. Ooh. And the exact servo usage I'm thinking is going to be for, I'm not quite sure yet, but I know I want this expansion to be possible. Let me grab these as well. There we go. Oh boy. There we go. Yeah. So what I'm doing now is I'm just making some space by moving the LED pin headers to add a few extra servos here. I'll call this spare servo 1, and I'll call this spare servo 2. The reason I want to include some spare servos is that in this animatronic, or in this future version of the animatronic, I might want to include a tail wag, just like this original animatronic had. This original animatronic could wag its tail in lots of different directions, but this new one would only need it to move in one. I'm not necessarily sure that I'll do that because the tail's on the back, which you don't really see while you're riding the ride. But the other thing I might want to do is a full body twist. So twist below these wings so it can twist in that direction and look around a little more. That might be something I want to add. depending on how it looks. And the final thing I'm thinking about is I might need to put a servo on each side, controlling each wing individually, depending on how the Stort platform fits in. And if I have to do that, then that is 2 or at least 1 extra servo than I already have planned for the wing flap. So I'm going to play it safe and include all of this from the get-go, so I don't need to try to fit it all in afterwards, which is a lot more work than just doing it right from the start. There we go. Then these pins can just come out a little bit more, straight up to 12. I'll pull these up. So I add the ground back, just like that. We have the ground back, and then I'll add these sensor back in. Not the sensor, but the LEDs. And like I said, it's not really that complicated. It's really a super simple schematic. There's a lot of lines going on, but it's really not too much you can't really understand without just looking at it. Each line is a wire, so I'm just running 6-volt and ground to each servo, and then a data pin to the servo to tell it where to go. Oops. I'm running a data pin to the server to tell it where to go. Data pins to each of the LED lights to turn on the eyes and tell them what color to be, and then receiving signals from the target to be able to shoot at the Yabbit during the ride. I just realized this got messed up while I was moving stuff around. That would have been bad. Let's put that back to where it was. Oops. That goes back. And then, ooh. This also comes back here, just like that. So this looks like a pretty good schematic to me. Pretty nice schematic. With that, I think it is time to do the final soldering. If we look back to where we left off last week, and I'll put Yabbit away, or the old Yabbit away for now. If I put him back and we look at the control board I have so far, I have the Raspberry Pi Pico W on board, which correlates to this sensor right here. This big block is the Raspberry Pi Pico, which is this right here. Then I have the 6 resistors for the LEDs. Oh, now that I look at this, I've already soldered this, so I might need to move. That's not too bad. Yeah, so now that I look at this, I've already soldered the LEDs in, so those pins are kind of set. So what I need to do is I need to move those back to where they actually are, which is 8 through 13, 8, 9, yeah. So basically, these final 2 servos get to come around the bottom, and then these all get to move up a few, just like this. Grab that. we go. Oh, not quite. There we go. I'll just come through and do that for every single LED. And again, the reason I have to do this is because I've already soldered part of the board before I finish the design. And the resistors for these LEDs were already attached to those pins. So I'm going to go back and retroactively correct the schematic to what's already built. Just like that. So now that we have that, we can come back to what we have physically built. And if we look at this, it's pretty simple. We have the 6 resistors for the LEDs. We have the Raspberry Pi Pico. We have the screw terminal for the power, as well as the jumpers, the 4 pins for the LEDs. And that's pretty nice, but it's not quite what we need fully. We don't have wires between the resistors and the pins here, which is something we need. And then we also need all the electronics for the sensors here, for the IR detectors, as well as all the sensors for the as well as all the jumpers for the servos. And one thing I just realized I really should have is on here, this shouldn't really be the sensor directly, because this is going to go to more pin headers, which then lead to wires within the animatronic. So what I'll actually do is I'll replace these sensors for 3-pin, 3x1, maybe I want 1x3. Here we go. Connector 1x3, here we go. And that will be the head target. And this will be the body target. So I'll just rename those from the start. Head target. Here we go. Boom, boom, boom. And then the same thing for down here. It gets to be the body target. Boom, 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 just like that. So, super simple. Head, body, head target, body target. Looking good to me. So the final thing to do is to actually solder this up. I'll come back here onto my camera and get a little better view of the soldering iron. Let's see, the best view we can get here. That looks pretty good to me. And while I'm soldering, I'll talk about whatever we need to for this design. I'm just cutting off these long leads. At the end of the last stream, what I did is I left these leads here long off the back of these resistors, and one side is soldered to the pins that go to the Raspberry Pi Pico. but I don't need them long anymore as I've already soldered them to the Raspberry Pi Pico. So I can cut these pins shorter and save a little bit of space, make it a little prettier. And then on the other side, I need to wire these resistors to the Raspberry Pi Pico, just like I did in the schematic. So if we look back at these resistors, I've already done this side where it connects to the Pico, and now I need to wire them to the pin header. So what I'm actually going to do is I'm going to start with the ground pin. And this ground is going to go directly to the screw terminal here. So that's this screw terminal here. So I'll start just by grabbing some black ground wire, as well as my wire strippers, which are just here. Cool. Let's see. While I'm online and just soldering, feel free to ask any questions you have about my channel, about my projects. If you need a refresher of what I'm doing here or anything like that, just let me know. I'm happy to answer any questions. Of course, this working like this and soldering every PCB by hand like this, it's not great, but it lets me get it really done. You see how fast I'm going from creating that schematic just a few seconds ago to working on the actual PCB right now. So it's a really fast turnover. It's pretty fast to still like order proper PCBs. It only takes a few days now. But it's still always nice to be able to work on it right away. Within just a matter of seconds, really. The only thing that slows this down is me. I'm almost wondering for the ground if I just use one of these leads and just like string it across. That's pretty gross. I'm not going to do that. So basically I need to wire ground, DC ground, from this pin, or this pin here, and I need to wire it to this pin and the following pin. And to do that, I will use some of this black wire on the top side. I see there's a lot of people jumping in and out of the chat. As you guys join, feel free to ask any questions if you want me to catch you up on what we're working on here, what this PCB is for, the animatronic itself that it's going into. All these questions I can answer. I can talk about anything related to the channel. Anything you guys want to know, we can work on, talk about. So just let me know how you guys, what you guys want to do. Otherwise, I'm just going to keep soldering, keep working on this board. One of the biggest pains when working on a board like this are the short little wires that you end up making. They're really hard to maneuver. So one of the tools I have is a really small pair of like jeweler's pliers. I need to find them though. Here they are. So I really like these jeweler's pliers for soldering. You can see how tiny they are just at the front. But it really lets me grab the little wires and bend them how I need to. And then once I have them bent, it helps me put them into the actual pinholes I need them in. Let's see, I want this one here. And I want to put this, whoa. All right. Sometimes bending these wires is such a nightmare. But there we go, we got that wire in. Then another trick to hold it in place before you solder it is to bend the leads over, like I'm doing now. Bend the leads over into where you want to solder them. So now that's a pretty sturdy connection, even before soldering. It's not a good electrical connection, but it's a decent mechanical connection. Until I just do a little dab of solder, and we're in. Little dab of solder, and a little solder bridge here, just like that. Then on this other side, little dab of solder, and a little solder bridge, and a final, not the final, but there we go. Nice and easy. So that's the ground done. And the next thing I want to do is I want to run the red, green, and blue color wires. So I'll do it like this, so that red is on top. So it'll be red, green, blue, red, green, blue. So I'll run red, green, blue, red, green, blue. And I kind of want to do this bottom one first because it sounds more annoying. There we go. I'll start with a blue wire. And just because I have the correct colors, I'll actually be using the colors correlated to the color LED. So this will be the blue wire. And this is a super short jumper. It needs to go just to there. So this one's going to be pretty fiddly to get into place. And another thing with these tiny little wires, when stripping them, you have to be really careful. See how I just like barely have that wire in there? It's just in there. It's pretty hard to maneuver, and it fell backwards there while I was showing you. So I'll just strip that, and that looks pretty nice. It's super tiny there. See if I can get to focus on it. Focus. All right, well, that's okay. I'll bend this back into right angles to start with, and that way it's easier to place it down right to where it needs to be. Blue goes into blue. Blue goes into blue. Oh, dang it. Let's see. These are probably going to be the most finicky wires right now, just because they're the tiniest little wires in the world. Kind of sucks, but that's okay. Tiniest little wires. There we go, bent over. And I don't think that one even has enough to bend over, but it's staying in place pretty well. So I'm just going to drop a little bit of solder right in there. There we go. Just enough solder to hold everything in place. Yep, that's not going anywhere. Then same thing for the other side, just some solder. Solder and a solder bridge connecting the wire to the pin. There we go. That is looking, it's okay. It's not the nicest thing I've ever soldered, that's for sure, but it's okay. So there's that blue wire in place, that blue one right there, right there. Next up, I'll do the green wire. This green wire can be a little bit longer, and in this case, longer wires are a little bit easier to work with. A lot of the times, longer wire is not easier to work with. Like, I know every single person in the world has had to fight with headphone cables. And we all know that is not the easiest thing. But in this case, when I'm talking about just a few centimeters, just like this, it's much easier to work with a little bit of a longer wire. It gives a little bit more maneuverability. It's a little bit easier to work with. So coming back to the solder view, I want to plug the green in next to the pin and next to the resistor. Come on, there we go. See how much easier that one was compared to the blue one? I barely had to fight with this one at all. I'll bend the wire over, the little bit of copper. There we go. I'll bend the other side too. I gave myself a little more room. There we go. All right, that's held in there nice and secure, so that means it's time to do just a bit of solder. Just enough to hold it in, and enough to make a little bridge. Then same for the next solder joint, just enough to hold it in, and enough for a little bit of a bridge. Make sure that's enough, there we go. So you'll see I just did these two connections, this one right here, this one right here, and that's this green wire on top. So then the final one for this LED is the red wire. Snip that, snip that. So let's get the red wire. Give the front a little strip. And a little bit of another strip. Bop. There we go. Bend it over, pick it up with the little tiny pliers, and mount it up just like that. There we go. Super nice. Like you saw there, just the slightest bit longer of wire, and it gets so much easier to work with. Compared to that first blue one I did, that red wire was such a breeze. Bend that over. There we go. That is looking nice. Just a bit of a solder point, and a little bit of a solder bridge. Bit of solder, and a little bit of a solder bridge. There we go. There's that red wire in place, just like that. And I'll cut the long resistor lead off. Looking nice, looking nice. All right, and then in the next step, I'll do the exact same thing, but for this next set of pin headers. So this is all the wires done for one of the LEDs in the eyes, and then I need the set of the next 3 wires to run to this one for the next set for the other eyeball on the animatronic. Hello, I'm seeing a few more people join. I hope you guys are enjoying the stream. If you guys have any questions, please feel free to let me know. Feel free to let me know any questions you have, anything you might want to know about the project. If you want a little bit of an overview, I'll be glad to give it to you. Or if you have any other questions about my channel or my projects, please let me know. I'm very glad to talk to you guys. Anything you guys want. So I'll solder this blue wire, strip it, and then bend it, and then get it into place. Give it a bit of a solder. Repeat for the green and red wire. Put one side to the resistor, and then one side to the pin header. Let's see if I can get that into place. Boom. There we go. All right, that's in place. Ooh. So there we go. That's the blue wire for the next eyeball done. Next up is the green. Just like last time, it's going to go blue, green, red. So let's get this green wire cut. We go green. Then we go to here. Just like that. And we cut it back again. Bend that back. Bend that back. There we go. And solder. Super simple system. Bend one way, bend the other way, solder. Nice and repetitive work. Pretty easy. There we go. Trim off the excess lead. There we go. That's that green wire in. And the last step is the red wire for the red part of that eyeball LED. There we go. Okay. Cool. And final step is to solder, solder. Let's make sure there's enough there for a bridge. There we go. So there we go. That solder point is done. And on the other side, we have all the wires to the LEDs. That's looking pretty good. Then next up, we have 2, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8. Next up is going to be the 8 pin headers for the servos. So if we come look at the schematic I drew, I just soldered on this part, so all these resistors, as well as the pin header for the eyeballs. And then next up is going to be all 8 of these servos. So what I will do is I have to choose where to lay out all of the pin header. I'm kind of thinking what I want to do is lay it out in a row just across here. Just like this. Lay it out in a row across. So I have these 2, then 3, 4, 5, 6, 7, 8. So I have plenty of space to do that, and I think that's how we're going to end up doing it. It's not the most beautiful design in the world, but it's not the worst either. I don't necessarily hate it. The other benefit of doing it this way, or I guess the main benefit of it doing it this way, is that I can solder all the leads together for the 6-volt and ground pins. So looking back at the schematic, every single one of these pins on this side, gets ground, or a 6-volt to the center and a ground to the servo pin to control the servo. So by laying it out like this, I'll be able to just solder it straight across the bottom and connect the ground and 6-volt all to each other with only a few wires running from the screw terminal, which will be super helpful. And again, while I'm soldering, please feel free to ask any questions, do anything, or talk about anything you want to talk about. I'd love to hear whatever you guys have to say. Oops. So yeah, this will all fit here. That's 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So what I'll do is on the back side, I'm going to find a way to hold all of these in place first. And I actually have just what I need. I have this row of female pin header. I'm just going to press that in here across all 8. Not only will this keep this vertical, they'll keep them all aligned. So I don't have to, oh, that actually makes it really nice. I keep it all vertical and aligned, so it's pretty easy, or even simpler, to solder in the controls or the pin header. And I'll take out this Raspberry Pi Pico to give me a little bit more space to work with while I solder. Let's see, give myself 2. Yeah, that looks good. So if I just put this down, just like this. There we go. That's looking good. Let's see. Ah. There we go. Let's see. Always a question of how to hold whatever you're working on. In this case, I'm really having trouble. Almost wondering if I can just pull this off and use it as a clamp. So what I'm doing now is I'm soldering some pin header onto this PCB, this perf board. And the reason I'm doing that is to connect a bunch of servos to this Raspberry Pi Pico to control the animatronic. This animatronic is going to end up on my ride, the ride I've been doing a bunch of work on my series, in my latest series on YouTube. This ride is going to be synced with this animatronic over Wi-Fi, which is why I'm using a Raspberry Pi Pico W for the Wi-Fi capabilities of that microcontroller. So like I said, it's a Raspberry Pi Pico W. It is synchronized over Wi-Fi to the ride vehicle. So as you're riding along, you pass the ride vehicle, or you pass as you're driving along, you pass the animatronic, and the ride will actually be able to interact with that animatronic. So for example, the animatronic will, it might be able to like attack you or blow at you or whatever, and the ride vehicle gets blown away. And because it's a trackless ride, I basically have infinite options for how the ride and the vehicle, how the animatronic and the other show scenes interact with the vehicle. So what I want to try here is using this bare piece of exposed copper as a animatronic, not as an animatronic, sorry, as like a bus bar across all of these pins, because I want all of these center pins to be tied to 6-volt power, and it'll be a little bit easier to solder if I have a bus bar running all the way through. Not even really a bus bar, but just like a piece of copper that runs all the way through, that conducts the current of the motors on the animatronic. It looks like this is going to work. I've never actually tried this before, so I'm pretty excited if this does work out. Which it looks like it is working quite well. And on top of the wire, I'm going to add more solder. The wire is actually just there to really kind of hold the solder while I'm doing it. I don't want it to be the main conductor because I don't think it's really thick enough. It doesn't have the ampacity for it. Ampacity being the capacity to pass amps through the wire before it melts. And given that this is not, like 22 gauge wire, it's not that much. Very low ampacity rating. So let's add some solder bridge on top to kind of fill in the gap and add some more conductive material. And just like that, that's looking pretty good actually. I'll snip this end off. And that's actually pretty nice there. You can see, if I get it to focus, that's a nice straight band all the way connected through on the animatronic head, or on this pin header. So all of those 6-volt rails are connected together just like that. Super simple, super nice. Then I'll do the same thing here for the ground rail. Let me cut another strip of wire off. There we go. Feel free to ask any questions you might have. Let me know anything you might be thinking about for the ride, for any of the projects on my channel. Please feel free to ask any questions. I'll be happy to answer them while I'm here on stream. More than glad to talk to any of you guys. More than glad. Just let me know. In the meantime, I'm going to solder another one of these bus bars to this ground rail. Pretty exciting that this works. It'll make soldering in the future much easier. Or soldering anything like this with the big connection of pins all in a row, much easier. And I just soldered the two far ends together. And now I'll be able to go through the other ends and solder all of those in place, or all the 6 in the middle. Super simple, very easy. I do have to take care so that I don't accidentally solder the 6-volt rail and the 0-volt rail together. That could be dangerous, to say the least. Not really dangerous. The power supply I'll be testing this with has current limiting capabilities. So it's not particularly dangerous. It's just unfortunate, because that just adds another thing to troubleshoot and another problem to solve, which is the point of engineering, solving problems. But it's not really the fun part of engineering. At least not problems like that. There we go. That's nice and soldered. So you see now I have these big thick bus bars on the bottom, big thick chunks of copper, of solder, and that connects the pins here that the servos connect to. So see, like if I pull one of these servo wires from the platform, it'll connect just like this, where each servo goes in a line down the platform, connecting in, creating a control board. Now, that's looking pretty good. I'm pretty happy with that. You can kind of see what I mean when I have all these servos plugged in. So you can see I've got the servos plugged in. They'll be able to be controlled and start moving. But what I want to do is I need to run the 6 volts from the screw terminals down to the actual bus bar, as well as the ground, and then I need to connect all the control wires to these servo pins. So I'll start with the power rails, because that sounds a little bit easier to me. Yeah. Let's start with the power rails. And for that, I'm thinking I'll use 2 or 3 conductors, because these are pretty thin conductors. And this is 8 servos. They are tiny little servos, but still, it's best to have some room there. So I'll take this. I want the ground to come from here. I'm kind of thinking I want to route it around the side here, down this other side onto the back rail here. So I'll cut it here. There we go. Very good. Very good. Route it around and to the side where it connects to the servo pins. And just like before, I want to take it and I want to bend it so it holds in place while I get the soldering iron ready. There we go. Looking good, looking good. All right. Oops. Let's get that soldered in. And I want another bridge here. Okay, this looks good. There we go. Then on the other side, I want to solder this here. Cool. Then, like I said, I want 2 or 3 conductors for both the ground and 6-volt power rails. And that's because there's a lot of servos here. So even, and this is pretty thin wire, so I want it to be nice and gotta have lots of conductive surfaces so that I don't burn anything up and I don't undervolt the motors or anything. All super important to not damage the animatronic. So again, while I am working on this soldering, while I am building this, please feel free to reach out, to leave any questions in chat. Let me know anything you want to know about my projects, my channel, this specific project. I'm happy to answer. Strip this wire, bend it down a little bit. There we go. There we go. Big, thick, and globby soldering. I want it nice and thick solder so it conducts lots of current for all these motors. And I'm thinking I'll do one more conductor. I haven't necessarily actually done the math to see how much current this wire can take. And I'm out of black wire. That's pretty awesome. That's good. So it's not like I've exactly done the math to see exactly how much current this wire can take or exactly how much, exactly how many strands I need or anything like that. But they are super low current motors. I'm not super worried about damaging anything in this case. It's not super hard. Or not super high current. They're super tiny little 9-gram servos, so I probably would have been fine with just one of these strands. There we go. I'll solder this bit on. There we go. And solder it on the other side as well. Make sure it connects to everything. There we go. That's in there good now. That's 3 strands running from the ground of the screw terminal over to the ground of the servo bar. And I think I'll do the same 3 strands on the 6-volt power rail. So let me strip some wire for that. Run it over to the 6-volt and run it down One of the things I'm thinking about right now is ordering of the wires that I'm putting in, because I can put this wire in right now, this red wire, this red 6-volt power wire, but I have to be careful to not block anywhere where I'm going to solder to in the future in just a few minutes. So as I cut this shorter and shorter, I need to consider how I run the wire to make sure that there's still ample access to right along this pin header where the Raspberry Pi Pico pins can be attached, as well as right along here where the other wire goes to. I think right like this is a pretty good compromise. It doesn't really block either of those while still routing power. But I definitely need to route the power first because wires are going to run right through this channel. A lot of wires are going to run right through that channel. So I need to make sure that's clear for all the wires that are coming in next. So then it's a little bit of solder and make sure it's a nice bridge. There we go. And same up here. Cool. So next up, going back to my schematic here, what I'm going to do is I need to connect these GPIO pins to the servo pins. And to do that, I just run wire effectively. So this Stort platform 0 servo goes to GPIO 0, which is this one here. And to run this, I'm thinking, let's just see what I have the most of. Probably yellow wire, because I haven't used any of that yet. I'll say yellow wire is good for the servo data pins. And that also kind of matches the actual servo pins, because the servo wires are orange. Which means, not which means, but which is convenient because we get the right color. But once again, I have to think about the order I'm doing things. because I kind of want to start here in the middle and work my way out to the sides so that as I fill in wire, I don't need to get back down there. So what's GPIO 7? GPIO 7 is there. That one looks like a good one to start on. Which goes to the third one. Okay. Yeah. Okay. This is good. Okay. Okay, so I bent that wire. Next up is solder it, just like every other wire I've done today. There we go. And same thing down here. Nice and soldered. And this is not a current providing wire. So it just gets one strand because it's only data. That was a nice and easy job. And then next up is the spare servo 2. So what I just did is I soldered this servo here and this wire. Next up is this servo here, GPIO 15 and spare servo 2. So going back to the solder view. Strip that wire, bring it back over here, pull it back, and snip it. Okay, and same thing here. There we go. One end in that side, and one end in that side. And then we bend the wire back to the other side, and bend the wire back to the other side. Cool. Wire's bent, so now we solder it together. Cool. So next up, I'm just going to keep working my way down. Back on the schematic, what I've done is I've soldered these two spare servos in. And next up, I'm just going to start working my way up this way. So next up is the wing flap and then the eye blink. Right now, what I'm doing is I'm soldering up a control board for an animatronic. Specifically, this animatronic is a remake of my Yabbit animatronic from long, long ago. This animatronic is this guy right here. Let me zoom out a little bit so you can get a better view. He's kind of got a round shape, a big round head. He has eyes that glow, lots of movement in the body, lots of movement in the head. So what I'm doing right now is what I'm actually going to do is I'm rebuilding this animatronic using a storage platform, just like this one right here actually. This side goes to his body, this side goes to his head, and what's cool about a storage platform is I'll be able to move it in all 6 dimensions independently. So that means I can lift it up and down, side to side, front and back, and then all the twisting you could ever want. And that will allow me to create a really, really emotive animatronic. It'll be able to display a lot of emotion. That's really good for an animatronic because just like in animation, what you want from an animatronic is a lot of emotion. So what I'm doing right now is I'm soldering up a control board. Earlier in the stream, I drew up this schematic for this control board. And now what I'm working on is actually soldering up a control board based on that schematic. So what I've been doing is I've soldered the pins for right here, these ones right here. I've soldered those, and those control the RGB LEDs in the eyes. And additionally, I have soldered up the RGB LEDs in the eyes. And now, right now, I'm soldering up all the servo pin headers to control the servos that make the animatronic actually move around. So I just soldered a big strip of pin header right there. And then the servos gets plugged into it just like this. So basically 8 servos in a row get plugged in. 9, 10 servos in a row get plugged in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Cool. So I'm going to keep working on it, keep getting some more wiring done. While you're online, please feel free to ask any questions you have about this project, about my previous animatronics, about my current ride project. Anything you guys want to know, please let me know. I'm more than willing to answer any questions you have. I really like this soldering iron I have. I forget the exact model number, but it is the one Adam Savage recommended on Tested. It heats up super fast. It's super nice. The only thing a little bit annoying about it is that it falls asleep. So if the gyroscope doesn't expect a lot of motion or doesn't sense a lot of motion, then the animatronic, then it falls asleep and cools down, which is a great safety feature and a great power efficiency feature. It's just a little annoying sometimes because you have to wait for it to cool up or warm back up. Luckily, it warms back up in like 10 seconds, so it's really not that big a deal. Otherwise, it's a great soldering iron. I've been using it basically as long as I've had this channel with great success. So yeah, please let me know any questions you have. Yeah, so I'm just soldering on connections for the servos, for all the servos that control the animatronic. Have you guys ever soldered anything like this? Do you guys work with breadboards a lot, or are you kind of, when you do projects like these, do you usually go straight to PCBs? I haven't actually designed a full PCB before. It's one of the things I want to do soon. Design a full PCB and get it designed or printed out and manufactured and shipped over to me. Sounds like a great tool, and it's something I'm going to need to do at work pretty soon. So, debating if I just wait and get that experience at work, or if I make a PCB for one of these projects first, get that experience, and then when I take it into work, it'll be a lot easier because the board I'm designing at work is a little more complex than anything I do here. There we go. All right. It's looking good, looking good. So I'm thinking what I'll do for this stream is I'll just solder up these last few connections. And then before the next stream next week, I'll finish soldering this board up, connect all the servos, and get the basis of a program going. So we'll be able to do something a little more engaging in the next stream. We'll be able to start actually animating the robot, the head at least, and maybe we'll be able to start designing the actual head of the robot as well, of the animatronic, and maybe the body. That sounds a little more fun and engaging for a live stream than soldering like I did this week. So let me know if that sounds interesting to you guys. I think it could make a really interesting live stream. We can start animating the animatronic a little bit. And I actually want to show you guys my plan for animating the animatronic. I want it to tie into the animation played back on the ride vehicle in this ride. Let me do this. So if you watch my previous ride vehicle, you'll see that I animated the ride in Blender. So I created the ride profile in Blender, and I can play it back almost immediately right back on the ride itself, which is super fun. It adds a lot of it lets me do a lot of cool things with the ride, because it lets me basically make whatever motion I want. But the reason I chose Blender is because I can also basically slap in any 3D model I want into the ride space. So if I take a 3D model of this animatronic, I can put it into the ride space of the vehicle and animate it in Blender next to the actual vehicle moving around. So I'll be able to animate them together, which will create a really cohesive animation where the two objects can interact. The vehicle and the Yabbit can interact while I'm animating it, so I don't have to like think through what it's going to look like. We can animate them together, and then we'll be able to play it back together, which will create a really, really cool ride. So let me know if you guys are interested in that. I'm sure it'll be a little more fun than this video, this live stream. So if anyone has any final questions for these last few minutes of the live stream, please let me know. Again, by the next video, I'll finish soldering this, and then I'll get working on the actual ride, or on the animation of this animatronic. And maybe in the next video we'll do some more design work, or we'll work on some more. We'll do some more design work, or we'll work on animating it. So either way, the next stream we do will be super cool, super fun. So please let me know what you want to see, and subscribe. Follow my Instagram to get notifications about any uploadings, any updates I do for this project and for my channel. So thank you very much for joining me on this stream. I'll see you guys next week. Be sure to subscribe and follow my Instagram again. It's great, great seeing all of you. Thank you.